All right, so solving trigonometric equations. I've been requested to do problems B and D from T4. So I'm just going to work through these. The basic idea is that you isolate the trig function itself, then you use your knowledge of inverse trig functions to get values that the argument could equal, and then you solve for the argument. So to walk you through this, we're going to start with B. First of all, we need to get the trig function by itself. So we need to take both sides and divide it by 2 square root 3. Now, for the purposes of this summer work, you may have noticed that all of these were basically going to be non-calculator problems in general. So this, we should be able to recognize as something. That 3 over 2 root 3 is super confusing though. So we're going to rationalize that so it looks a little easier to work with. So when we do that, we end up getting 3 root 3 over 2 times 3, which is 6. So that's going to simplify down into root 3 over 2, and that's something that's on our unit circle. So now we're going to use our knowledge of inverse trig functions in the unit circle to figure out what the argument should be. So we want to know where cosine equals root 3 over 2. So if you think on the unit circle, cosine is root 3 over 2 at pi over 6. It's a 30-degree angle. Cosine is the x value, so it's also at 11 pi over 6. Now, I'm writing that on 2 separate lines because that's going to happen every time we go around the unit circle a full time, right? Every time we add any integer multiple of 2 pi. So I'm going to add to each of those things 2 pi n, where n is an integer. Now, z, capital Z, I know is weird. It's the symbol for the set of integers. So when you see that at the end, that's what it means. You could just write n as an integer and that would be fine. And we're going to do the same thing here. Now, when you do that, that is what the argument of your trig function equals. So that's what pi x equals. It's not what x equals, it's what pi x equaled, because that was the argument, what was inside. So to finish solving, we're going to divide both sides by pi. So when we do that, the pi over 6 will become 1/6. The 2 pi n will become 2n, where n is an integer. And then the same thing for the 11 pi over 6 and the 2 pi n down here. Now, looking at D, again, we're going to start by solving for the trig function. So we're going to isolate the trig function. But now we have secant, and secant is not something we know in the unit circle. What we do know, though, is that secant is the same thing as 1 over cosine. So now I can multiply both sides by cosine, and then we're back to solving to get the trig function by itself. 1/2 is something we definitely know in the unit circle, so x is going to equal. Now cosine is 1/2, again it's the x value, at pi over 3 and at 5 pi over 3. And that would be true for every integer rotation of 2 pi. It would land at the same spot. And this time the argument was just x, so we don't have to do any extra steps at the